In the field of video compression, a video frame is compressed using different algorithms with different advantages and disadvantages, centered mainly around amount of data compression. These different algorithms for video frames are called picture types or frame types. The three major picture types used in the different video algorithms are I, P and B. They are different in the following characteristics. Euro frames are the least compressible but don't require other video frames to decode. Euro frames can use data from previous frames to decompress and are more compressible than Euro frames. Euro frames can use both previous and forward frames for data reference to get the highest amount of data compression. Summary. There are three types of pictures used in video compression: Euro frames, Euro frames and Euro frames. An Euro frame is an intra-coded picture, in effect a fully specified picture, like a conventional static image file. Euro frames and Euro frames hold only part of the image information, so they need less space to store than an Euro frame and thus improve video compression rates. A Pascal Euro frame holds only the changes in the image from the previous frame. For example, in a scene where a car moves across a stationary background, only the car's movements need to be encoded. The encoder does not need to store the unchanging background pixels in the Euro frame, thus saving space. Euro frames are also known as delta Euro frames. A Euro frame saves even more space by using differences between the current frame and both the preceding and following frames to specify its content. Pictures frames. While the terms frame and picture are often used interchangeably, strictly speaking, the term picture is a more general notion, as a picture can be either a frame or a field. A frame is a complete image captured during a known time interval, and a field is the set of odd-numbered or even-numbered scanning lines composing a partial image. When video is sent in interlaced scan format, each frame is sent as the field of odd-numbered lines followed by the field of even-numbered lines. Frames that are used as a reference for predicting other frames are referred to as reference frames. In such designs, the frames that are coded without prediction from other frames are called the I-frames. Frames that use prediction from a single reference frame are called P-frames, and frames that use a prediction signal that is formed as an average of two reference frames are called B-frames. Slices. In the latest international standard, known as H264/MPEG-4AVC, the granularity of the establishment of prediction types is brought down to a lower level called the slice level of the representation. A slice is a spatially distinct region of a frame that is encoded separately from any other region in the same frame. In that standard, instead of I-frames, P-frames, and B-frames, there are I-slices, P-slices, and B-slices. Macroblocks. Typically, pictures are segmented into macroblocks, and individual prediction types can be selected on a macroblock basis rather than being the same for the entire picture, as follows. I-frames can contain only intra-macroblocks, P-frames can contain either intra-macroblocks or predicted macroblocks, B-frames can contain intra, predicted, or B-predicted macroblocks. Furthermore, in the video codec H264, the frame can be segmented into sequences of macroblocks called slices, and instead of using I, B and P frame type selections, the encoder can choose the prediction style distinctly on each individual slice. Also in H264 are found several additional types of frames: slices, Euro frames slices. Facilitates switching between coded streams. Contains SI macroblocks. Euro frame slices. Facilitates switching between coded streams. Contains P and or I macroblocks. Euro frame motion estimation. Euro frame motion estimation will allow increases in the quality of the video while allowing the same compression ratio. SI Euro frames will allow for increases in the error resistance. When such frames are used along with a smart decoder, it is possible to recover the broadcast streams of damaged DVDs. Intra-coded frame slices. I-frames are coded without reference to any frame except themselves. May be generated by an encoder to create a random access point. May also be generated when differentiating image details prohibit generation of effective P or B frames. typically require more bits to encode than other frame types. Often, EO frames are used for random access and are used as references for the decoding of other pictures. Intra-refresh periods of a half-second are common on such applications as digital television broadcast and DVD storage. Longer refresh periods may be used in some environments. For example, in video conferencing systems it is common to send iframes very infrequently. Predicted frame slices require the prior decoding of some other picture, S, in order to be decoded. May contain both image data and motion vector displacements and combinations of the two. Can reference previous pictures in decoding order. Older standard designs use only one previously decoded picture as a reference during decoding, and require that picture to also precede the P picture in display order. In H.264, can use multiple previously decoded pictures as references during decoding, and can have any arbitrary display order relationship relative to the picture, S, used for its prediction. Typically require fewer bits for encoding than I pictures do. Bidirectional predicted frame slices require the prior decoding of other frame, S, in order to be decoded. May contain both image data and motion vector displacements, or combinations of the two. Older standards have a single global motion compensation vector for the entire frame. Some standards have a single motion compensation vector per macroblock. Include some prediction modes that form a prediction of a motion region by averaging the predictions obtained using two different previously decoded reference regions. In other words, some standards allow two motion compensation vectors per macroblock. In older standard designs, B-frames are never used as references for the prediction of other pictures. As a result, a lower quality encoding can be used for such B-frames because the loss of detail will not harm the prediction quality for subsequent pictures. In H.264, may or may not be used as references for the decoding of other pictures. In older standard designs, use exactly two previously decoded pictures as references during decoding, and require one of those pictures to precede the B-frame in display order and the other one to follow it. In H.264, can use one, two, or more than two previously decoded pictures as references during decoding, and can have any arbitrary display order relationship relative to the picture, S, used for its prediction. Typically require fewer bits for encoding than either I or P frames. See also, keyframe term in animation, video compression, intra-frame, interframe, group of pictures application of frame types, Datamish, video, references. External links, video streaming with SP and SI frames.